Hello everyone, welcome to the event conducted by Developer Students Club, Maharaja Agreshin Institute of Technology. So today's event is about progressive web apps. So right before jumping on to the event, we would like to introduce ourselves. My name is Ayush Parashar and I am currently in third year CSC department and I am studying in MAIT. I am a web developer and I had started it from
You are not audible.
both, sorry, am I audible? Hello. Acha, okay. So I always try to find, apart from the conventional front end and web end tech stacks like HTML, CSS, JavaScript. I like to also tend upon the new technologies that are coming to this field, like JavaScript libraries, PWA app, etc. So if you want to connect with me, you can connect via LinkedIn. My link is given here, linkedin.com/in/ayush-parashar. So and that is my LinkedIn ID. And apart from this, there is my friend Rupam Garg. He is currently studying third year IT department in MAIT itself, and he is a freelance web developer. And he loves to work on JavaScript, React, Node.js, completing the full stack and creating applications on the same. And you can connect with him on LinkedIn via linkedin.com/in/Rupam Garg 1. Okay, so coming right on the event. Here are the contents that we are going to provide. First is what and why, an introduction to JavaScript promises and events. I hope you know the basics of JavaScript. So then it is the most important thing, that is the introduction to service workers and their life cycles. Then requirements for PWA. What are the requirements for converting your native app or your web application towards a progressive web apps? So how to install it on your home screen, different caching strategies and live demo. So how to install it on your home screen, different caching strategies and live demo. So how to install it on your Okay, so starting with what and why. So what is basically PWA? I think that most of you don't know the exact terms that what is PWA. So dissecting the word, it becomes progressive and web apps. Web apps, as you know, that they are the simple web applications that you make by React, HTML, CSS, JavaScript, and other frameworks. So that is but the word progressive means here that you can enhance your existing file or your new that you are just about to go in the files. So they will tend to enhance at a progressive level. So as you can see on the slide, progressive web apps are built and enhanced with modern web APIs that are used to deliver enhanced capabilities, reliabilities, and installabilities while reaching everyone. So you must ask that why should we use PWA over native apps? Like what is the reason? Because you can simply learn Flutter or Kotlin and you can do it exactly the same way. But there are some disadvantages in native apps that we are going to overcome on PWAs. Like you know that we have to install it from app stores or Google Play Store, Microsoft Store, anything like that. So coming on the first part, it is the accessibility. As you know that you must quite use your smartphones, and there are most popular 3 or 4 apps that you regularly check, and other 15 to 20 apps, they are just lying there, and eventually you need to just uninstall it for the reasons that are given, like app wasn't used, they didn't fulfill the needs, or your phone has lagged the storage space. So that's why if I say that you can get a maximum reach via your URL, that you don't need any Play Store to install it, and you don't need to regularly update from the Play Store or apps or anything. You just have to create it for once, and you can regularly update it without any further delays. Next point is autonomous functionalities. Like there are some things that we are using with service workers, which will be show soon, that a PWA can work in offline mode also. Like for example, if you don't have reliable web connection, but you just send a image or anything to the browser. So it will continuously try to background syncing it, and when as soon as you get some reliable source of Wi-Fi or mobile data, it will just continue its functionalities. And also you can get the same push notification that you get in your native app via progressive web apps. Like you are using your Google Chrome or Instagram, anything, and you just get push notification even though you are using Chrome or any other browsers. And as I said earlier, it is very easy to update your app. And also SEO optimization. Like everyone thinks that their website or their blog should always rank number one in the Google searches or Bing search or any searches. So that is done via SEO, mm, that is engine optimization. So by integrating the PWA with your this Google, so you can just increase your index, that is the search engine index, and that you can what do you say, that easily install it, easily load it without any further delays or disruptions. Another thing is that cheap and fast development. As budding entrepreneurs, startup guys, or even like students, we always have a crunch of either money or time. So it is really a great option to use PWA. That most of the people are just progressing towards PWA because it takes less effort and time. It is more cost efficient also. Okay, so here comes a little bit brief introduction of promises and events. But I would like to share one more thing. There's a site called PWA Stats. Here you can see all the credible sources like Thomas Kent and even Z5. You must know that Starbucks. They are all given their responses that how PWA has given them the opportunity to expand itself. So, for example, like this, Starbucks PWA has increased their daily active users twice. Orders on the desktop are nearly as same as the as that of the mobile. So they are competing with the native apps, and you get the advantages of both native app as well as the web apps. So this is a cool site. You can just click on it and check it out. It's pwastats.com. So coming on to the slides. We were on JS promises and events. So what do you mean by promises? You must know that it is easily given in the flowchart also, that the promise object is a use for asynchronous computations. It represents a value, you can say, which might be available now or ever, like in the future itself. So there's no restriction that you have to just use it right away. So if I explain this flowchart, you have a promise, and then it has two options, either to fulfill it or to reject it. If it gets fulfilled, like you must have learned JavaScript, there is a try and catch block. So if it gets fulfilled, then we go to the then, and we compute the asynchronous actions, and then we return the promise. So, and if either 1% it gets rejected, then it will be used in catch on rejection. So it is basically used for error handling. Then the same thing, you can just chain regular events of then and catch to get error handling or asynchronous actions. So here is given one small program to get to know that what is actually a promise. That you can see there's a constant wait. So actually it gets a object which has two arguments, resolve and reject, as I said earlier. So here we have given the function set timeout, and if the time is less than 2 seconds it will get resolved, or other than that um, it will get rejected. So you must have if you have learned Ajax, you would have seen that there is XML request and all. So that is used for Ajax, but it is the promises and fetch APIs. They are just alternative to it, and I would say a better alternative. So you can see that we have done a promises with async and await that is used to prevent the callback hell. You must have seen that when we use callback functions, we are tightly grappled in the web of callback functions, and it is just like a situation of callback hell. So, for example, suppose we have made a request to fetch some data from the server by using the promise. If we get the data by server successfully, we will consider a promise as resolved or completed. But in case it doesn't get from the server, we will just reject it or it is not completed. So that was promises and fetch APIs. Coming on to the events handling in JavaScript, we can just basically define events as anything, any changes that are occurring on the web page. It could be as that web page has finished loading, or if you have hovered the cursor over any particular block like an image or a span, and if the input field was changed and button was clicked, all these are events. So the service worker, which is the next slide, they are regularly interacting with the events, and they are actually used to fetch that events. So here's the events handling a small code. Like we have set a button that is in the HTML file. So we can get the element by ID. The ID is the button. So here we have set the event to click, and as soon as the user clicks, we are giving the alert hello, that there will be a alert box which will get hello. So that was pretty simple, but now comes the main topic about progressive app, the core topic, that is service workers. So we have given the repo, the DSC MAIT. You can check it out at Developer Students Club MAIT / PWA session. So what is basically a service worker? You might know that the JavaScript works on a single thread. It continuously interprets and interacts with all the HTML pages, CSS pages. You have to write. You must know that there is a tag called script, and then we attach it or link the JavaScript file. But in case of service workers, it is little different. In case of service workers, there is only one uh, a parallel thread to the one thread, and there is only one JavaScript file called service worker, which interacts with all of the HTML files that are in the core file or folder. So it is a special script that your browser runs in the background, separate from your page. It essentially acts as a proxy, intercepting and handling network requests from your page. So as I told you earlier, that it interacts with the events, that specifically service workers listen to some events. That events could be some fetch APIs or background syncing, push notifications, how the user will interact with the push notification as soon as he or she clicked it. So before coming on to the life cycle, I would just like to tell you that if you successfully completed building your PWA app, and you want to know that how can I just confirm it that whether it is PWA ready or not, then you can go to the site called PWA Builder, or you can also use Lighthouse, which is a developer options in Chrome. It is not accepted in Mozilla Firefox and Edge right now, but it will soon get implemented there. But in PWA Builder, you don't have to do anything. You just have to enter your URL. Suppose I say instagram.com, and it analyzes and gives you a score. Score is given right here in the top. So you will learn about manifest right in few seconds, and this is the service worker here. So like in manifest, Instagram got 40 out of 40. That's pretty cool, and total overall score is 60. So you must know that all the leading or top tech stacks like Instagram, Facebook, Financial Times app, all are progressing towards PWA now.
So now let's talk about the actual working in the browser of this service worker. Let me share my screen. Okay, so this is a repo you have to clone. The repo link also present in the description of this video. So I have already cloned this repo. You just need to go into the public folder, and inside the src folder you just need to create a new service worker file named sw.js. So this is the file where we write our all the service worker code. So as our lifecycle has two, we have two lifecycle events that are, first one is install and the second one is activate. These events occur when a new service worker takes place into for a website into a browser. So let's start with activate. So let's start with install event. For that we need to write self. Self is nothing but just a reference to a service worker for our web browser, and we can add event listener just like that. Inside that we need to first give the name of the event, and then the event, and then a callback. Inside the callback we always receive a event object that contains all the details about the event. And for now just we will console something on the console so that we know this event has occurred. And I'm writing like installing service worker. After that we have second event at the time of at the time when the service worker initialized, which is activate. Here also I'm writing something like activate service worker. But in activate service worker we generally do one thing every time, like is that we are claiming the browser that this service worker is running for this same website. This is just for the verification for the browser that this is the same javascript file for which it is containing a service worker. For that we will write self dot clients dot claim. So this is the simple line. Actually this is not the correct clients. So this is a simple line that tells browser that this is the we are claiming the spot on the service worker thread. So let's try to see it in action. To start this project we need to do two things. The first one is installing the dependency. We basically just have one dependency, which is http server, which is used for running running our website on a server. So to do that we can just need to write npm i, which is installing all the dependencies, and then we can call npm start. After starting the server we have few links where we can visit to see our website. I'm opening and I'm opening it in incognito mode so that our my extension doesn't interfere between my work. So this is the website. As you can see, this site take a lot of time to load, even in the localhost, because of this, because of all of this assets, heavy assets. So what we do in this session, we will convert this we will convert this normal JavaScript website into a progressive web app, so that this website can load lot faster than it is running at the moment. So to do that, to check our service worker, we have we have applications. Inside applications we have service workers. Inside service worker we have few options like offline. If I check this box, then the browser will act as if what if I have no internet connection. So now try to refresh this. So it doesn't show any. So it doesn't have the actual content because it didn't connect it with the internet. Okay, so we will try to make it offline accessible as well. So let's start with lifecycle methods. We have written the code for lifecycle. Now we just need to tell the browser that this is a service worker file, and you have to start installing and activate this file. To do that, we need to go to the app.js file inside our
Bhuvan, I
JavaScript
just
folder.
want to interrupt. The size is too small. It is not visible on YouTube Live. Could you
The
please
font size,
Yes.
is it now okay?
Yes. Thank
Cool.
you.
Cool. Thanks. So inside the app.js file, we need to check if the service worker is installed on is if the service worker service is available on our browser or not. To do that, we will just write a simple if statement where we check service worker in navigator. Navigator is just simply our browser. Inside this if block, we will register our service worker to the browser by writing just navigator dot service worker dot register. Inside the register, we need to get the path to our service worker file, which is /sw.js. That's it. Now let's see this in action. So this is our service worker. This is our project, and as soon as page refreshes, the first event occur installing the service worker, which we will log from our service worker file. Then the activate service worker event occurred. So also check this out in applications tab. So here is our new service worker. If I click on this, I will get the code for our service worker. So one more thing I want to show is if I open this in the new tab and see my inspect mode again and install and activated service worker install and activated again. Now what if I change my service worker code a little bit? So this is my code, service worker code. I'm writing something like activating service worker 2. So just a small change. I need to change anything. And now when I refresh, as you can see, the new service worker go into the waiting state. That is because the older version of a service worker is still running inside this older tab. So to run our latest version of our service worker, we need to skip waiting. This is the one option. And the other option, if we have just only one tab with running our service worker, then this is happening automatically. So this is good for debugging purposes. And the second thing, so this is our life cycle of service worker. Then we can call activate events like fetch, sync, but that are not a part of the life cycle. We will cover those as well in our next lecture. So now comes to the requirements for PWA. So for a app, for a normal web app to be a PWA, it must fulfill 3 criteria. The website should be served from the HTTPS. The second one, the website should contain a manifest.json file. The third one is the website should be offline accessible. So how to do that, we will see now. And so whenever you visit a PWA, any progressive web app online, the first or second time you will see a small pop-up that comes out which says install this app on the home screen. install this as an app on home screen. So how can we make our website eligible for that pop-up? To do that, in Chrome we need to adapt this certain criteria. The first one is the app must be not already installed. Why would we then see this? The second one is meet the user engagement heuristic. That simply means if the user come second time on your, at least 2 times on your page in within a 5 minute of time span, then that pop-up will come up to the user screen, and from there they can directly add your website onto a home screen. The third one is the page must be served from HTTPS, and next one is the page must be offline accessible. If user don't have internet, it must have something to say that you are offline, you have no internet connection. That must not be the default browser page. It must be your site that is showing on the a manifest file is something that contains all the description of your website. So for like short name and name of your app, icons of your web, icons of your app for tab icon, all those kind of icons, and the start URL. PWA can also have a start URL. Like you won't, if you have an app, you won't let users want to start from your landing page. You want to start them from your login page. So in that start URL, you will define when user click on your app icon, which is the first page that is showing on his screen. Then we also have a display property inside that. Display, we can set different kind of display, like full screen mode that takes full screen of the user, as it said. Standalone view is the um, as you can see, any native app that as you open any native app, it takes all your screen and adjust your toolbar according to that. So that is the standalone view. Minimal UI is simply just a standalone view, just that. Minimal UI has the URL in the top and then the site title on the top. Generally, we use standalone for PWAs. And then what if we don't have a PWA, but we have a native app? So we can also point to that by using this property, prefer related application. So this is the criteria. Now, before moving on caching, let's try to implement this criteria and see this in action. To fulfill this criteria, we need to create a manifest file inside our public folder, manifest.json. And one more thing that, as I said, and the page must be served from HTTPS. There's one exception. If the page is running from localhost, then it doesn't require to be on HTTPS, just for development purposes. So in the manifest.json, we need to write some JSON data so that we can describe our app. So we have some properties we need to mention here. The first one is name. Let's give it name something like DSC projects. Then we need to give a short name that will be shown below the icon of our app, which is a short name. Let's say projects. You can write anything, just what comes in my mind I'm writing. And then we have a start URL. Start URL, as I said, the first screen that shows to user when they log in, then they start their app. Index.html. Then we have a display. Display, I'm currently giving this standalone view. And then we also give a background color. Now the background color, whenever you install a PWA, when you click on icon, it doesn't immediately start it. It shows a splash screen, as your all the native apps you see on all the native apps. It shows us splash screen, and For that, we need to give it a background color. The background color of your splash screen is, you can say anything. I'm giving it black. Then a background color, then a theme color. The theme color is the color of your toolbar above your app. I'm giving this one is, as our theme is pretty dark, so black as well. And then the description. Inside the description, you can give some description like, let's build something cool with PWA. And then we can also define a language we are using. So this manifest file, not just for PWA, this will also help in our SEO purposes, as we are specifying all the details of all the basic details of our website here. So our SEO is also improved from this manifest file. Orientation. Now here comes the orientation part. Orientation is for example, you are using the website in the native mode, in the portrait mode. So you can give a portrait. Primary. Then we can also give icons. In the icons, we need to give all three kinds of icons are necessary. The first one is 144 into 144 pixels. The second one is 192 into 192. The third one is 512 and 512. So I'm giving, so every icon takes 3 parameters. SRC, assets. So here's my icons path, logo 144x into 144.png. Then we will provide a type of image we are providing as an icon. And this is a PNG image, so I'm writing image/PNG. And then we will provide sizes. This is 144, sorry, yes, 144 x into 144. Then we will copy paste this 3 times and just change the sizes. The second size is 192. The third size is 512, I guess. Let me check. Inside images, yeah, 144, 192, and 512. So remove this. Okay, so our manifest file is ready. Now we need to add this file into our index.html. To do that, we will just create a link tag and give it related to manifest, and give the reference URL, which is our root. So here it is, both are in the same folder. Now let's see this in action. So currently there is no manifest file, but if I refresh this, I got the manifest file. So it contains all the icons I have provided and the theme color, the start URL, and everything that I mentioned there. You can also use this manifest for debugging if you want to show that if you want to show that the same manifest file as you are working on is installed on the website. And here are some warnings as well. The first one is the page is loaded in incognito mode. This is just because I'm using incognito mode, just for just no extension can interfere our work. And the second warning is the page do not work offline. So we will work on this later when when we study about caching. So let's now talk about caching. After the so in the criteria process, we have filled two boxes. The first one, the manifest, has been created. The second one is uh, HTTPS or localhost. So two criteria are ticked. The third one is offline accessible. To make our page offline accessible, we need caching. So caching is something that memory inside your browser, which contains your static assets, which can contains your static assets for that can be used later when the user don't have the internet. So we can provide the data from those cache memory. So our web API provides a cache API that simply just a key value, simply just a structure of key value data structure, where the key is the request URL and the value is the response of that URL. In the caching, we have two kinds of strategies. The first one is static caching, and then the dynamic caching. Static caching is something what you did at the time of installation. You are doing caching at the time of installation. Then you are using those cached elements whenever they needed. So let's try to do this in action. Let's get back to this code and get back to the service worker file. Inside this file, we are installing our service worker here. So we need to cache our assets inside our install event. To do that, we need a function from our cache API, which is so first open up our cache. We have a object caches where we can open this cache object is provided by the browser Windows object. Now we need a name for our cache object. We will provide it a name like const cache static name, and this is static v1. So static v1 is the name of our cache, static cache, and I'm just copy pasting this here. So when this cache is open, it will give me a object of cache that specifically pointing to this static v1 object. And to do that, we write in then let's write it cache without s. So this is our cache, static v1 cache, and we will just add all the static assets we have for our website inside this cache. So cache has some methods to add certain elements. The first one is add. The second one is add all, which is useful for us at the moment. Add is simply was just take one file and make a network request and store a response as a in the cache. And add all takes an array of requests, which is like that. And it will also store all the responses for each request. The first page we need to target is our root page, and the second page is index.html. The third one is then our JavaScript sources, like all our assets, static assets, our JavaScript files, CSS files, and all these things. Let's write it one by one. So inside src, inside JavaScript, we have app.js first. Then we have cursor.js. Then we have debounce.js. Then we also have externals /parent.js. And this is our JavaScript sources. Now we will need to add our styles, which is src/css. Yes, CSS. Inside that we need just a style.css where we have all our compiled CSS code. Style.css. Then after the CSS file, we need to add our assets like videos and images, which is inside this assets folder. So let's first add this video, which is running in the background. src assets. We need just about.mp4. And then we have all the images. We need 4 images from that. Images slash cover, which is the cover image for our video. Then we have 4 images for cards. We will copy this 4 times. One is Halloween. The second one is horror. And then the movie. So this is all our static assets. Now let's see this in action. One thing I want you to notice is that this is an asynchronous event. When the install event is occurred, it doesn't stop for this event. So to stop installation until this caching is done, we can write something like event dot wait until. And close this brackets here. And this is it. Just this wait until function will wait for this thing to be completed, so that it will complete the installation part and execute other things. So let's try to see this in action. Here it is. Now go to service workers file, and let's just, as you can see, the cache is empty at the moment. Let's just refresh this page, and we need to skip this waiting. And as soon as we skip this waiting, we have something in our cache, which is our all the static assets. Now we can again try to go offline and try again. So this doesn't work again. The reason is we just cached our data, but we never send our browser to go to our cache and respond from there. Now we will do that. To do that, we need to intercept our fetch event. The fetch event is occurred whenever our browser wanted to send a network request to a server. For that, we can write self.add event listener. The event name is fetch, and we also receive an event here as well. Now inside this event, we have a function named respond with. This will tell our service worker to which response he need to give at the client. Respond with. So first we will try to find the data in our cache, if we match anything inside the cache, so we will return that only. Event dot request, which is our URL. So this line basically tells the browser to, whenever a fetch event occurs, just respond with whatever you have inside cache with this URL. If they don't have anything like this, so it doesn't return anything, it just throw an error. We will handle that error as well as soon we go ahead. So now try to refresh this again. Skip waiting. And now go to offline mode. Let me just refresh it again. Okay. So this is our service worker. Inside the service worker, we have this code. We are here responding with caches. Okay. There is a small typo. It is not caches. It is not cache. It is caches.match. So we will try again. Just go to applications tab again and refresh the page. Make it online and refresh again and wait for it. Let's check the service work file. Now it is caches. Now try to go offline. And it still work even in offline mode. So this is the purpose for today's event. We want to access this page even in offline mode. So beside this, I also wanted to share something about other caching strategies. The second one we have is dynamic caching. Dynamic caching is something like, in this case, in the static caching, you know all the URLs you are requesting to, but sometimes you don't know the URL you are requesting to, like some file inside your folder structure, maybe sending a fetch request to another server that you don't know. So in that case, we need to tackle that case as well. In that case, the match is returning a error. So we write it then. Inside the then block, we have the response from the cache.match. Now, if we receive a response from the cache, we will return it simply, return res. But what if we don't receive any response from the cache? Then we will try to make our network request to the API or anything to the network, so that we can get that data. If we get that data successfully, we will store that data in our cache and use it for later purposes as well from our cache. So after making a fetch request, let's make a fetch request first. Event dot request is our URL. Inside then we have our response from the object from the URL, and inside f we will check the response. If the response is null or the response status code is different than 200, this is just a use case. I'm assuming that if the URL responds with 200 status code, only if it is a valid output that I wanted. Other than else, I will just return the response and do nothing with the cache. So this is response justice dot status. I should give it response because I'm using response already. response dot status is not equals to 200. So these are two cases that I don't want. So in this case, I will return the response as it is and don't do anything with my cache, so that our JavaScript code can handle this, whatever the data received from the server. And then what if I receive a valid response? In the case of valid response, I will try to first store it in our cache. Let's do that. Const, and I will create a variable for our response to cache, and this is our response dot clone. I'm just cloning the object so that I'm not changing anything inside the actual object provided by the server. And then just open my cache memory. Now I will create a dynamic. This is a dynamic cache, so I don't know the name earlier, so I will create a dynamic memory for that. Const cache dynamic name dynamic v2. Now we can provide the name of our dynamic memory here. And this will also give us a cache object where we can play now. Now inside the cache, I want a put method. Before that, I am using the add. Add is something that take a URL and make a request by their own and receive, and whatever they respond with, whatever they get the response, they store it with that URL. Now put is used to customize that process. In the put, we give a key and a value, so that can be stored on the server. Sorry, our cache. So first we will add the URL in event.request, and then we have a response in our cache object, response to cache. So this is it. And also we need to respond with our cache, also respond to our JavaScript file where this request is coming from. And this is it. We will first check if the response is present in our cache already. If it is not present, we will make a network request here. And if the network request has come up with something, we will first store this in our cache by this put method, and then return the response to the JavaScript, our JavaScript code. So this is about dynamic linking, dynamic caching. Now we have different caching strategies for different websites, different use cases. Here are some of them. The first one I want to talk about is cache only. The cache only, the first one we use in our code, where we just create, where we have two things, a client and a cache. Client send the request to cache. If something found in cache, then the cache responds with that. And if something not found, that will simply just generate an error. Then we have network only. Network only might be useful for some cases where we don't want our cache to interrupt our outputs. So here we just have two things, client and server. Client send the request to server and server respond with some output. Then we have, this is pretty interesting, cache then network. First we will check if we have something in our cache memory, and if something is present in our cache, then we don't go to server, we just respond with the whatever we have in our cache, we respond to the client. In case the cache doesn't have anything that is matching that key, we will go to server, and when the server responds with something, we store it in the cache and also respond the same to the client. Then the last strategy we have is race between cache and server. This is pretty interesting, and it is the most useful technique. Here we here we create a race between. We will make both the requests. We will first go to cache and also simultaneously go to a server. Whichever respond first, we will paint UI with those data. And for example, we have cache response, first and the server response second. So we will paint our data with cache firstly, and when the server respond, we will update our UI with the server responded data and also update our cache. In the second case, if server win the race, we don't bother about cache. We just update the cache inside the memory. We don't bother about changing the UI. So this is all about for today. And
So before the doubt session, we would like to inaugurate the next event that is going to happen. That is the Demo Day Halloween Special. So in this day, the DSC core team will try to showcase their projects that they have made. So the date is 7th November 2020, and the RSVP link is given as shown in the slide. It is https://bit.ly/DSC Demo Day. So I would like to tell you that note eligibility criteria for becoming a member will also be discussed during this event. So make sure all the members of DSC, all the participants also attend this. Thank you.
now you can ask doubts and queries if you have any.
Rubam, I think we can wrap up the event.
Okay.
Okay, thank you for everyone for attending this, and hope to see you soon also. Thank you.
Thank you.